So here we're looking at the percentage increase or decrease, so how much a result has gone up or down, bearing in mind the original value. So for this, we need a specific equation. So it's going to be an increase or a decrease of a result. So this happens over time, so we're working with two numbers. We're going to have the new number, or the new value, minus the initial value, or the old value, divided by the initial value. So we need to multiply this by 100 because it needs to be as a percentage. So if we wanted to go and use an example of an increase, in 1986, the number of deaths due to tuberculosis was 50,000. This then rose to 86,000 in 2003. So what was the percentage increase of deaths due to tuberculosis? So first we need to find our numbers. So the new number is going to be 86,000. The old number, or our original number, is 50,000. Okay, so we found our numbers. Now we need to minus them from one another. So we need to find our new minus our old. So our new number is 86,000 minus 50,000. So it's going to give us 36,000. So we take our difference and we need to divide it by the old value. So 36,000 divided by 50,000, which gives us 0.72. So remember, this needs to be as a percentage, so we need to multiply it by 100, and that gives us 72%. Now, if we wanted to go and apply this to one of our required practicals, so our osmosis, so as part of an investigation to find the water potential of potato cells, discs of potato were added to different concentrations of sucrose solution. The potato discs were weighed before they were put into solution and left for 20 minutes. After potato discs were removed from the solution, they were weighed again. The table of results is shown below. So calculate the percentage change in mass at each concentration. So here we can see it's saying at each concentration. So we're going to have two different equations here. So our first one, we're going to be looking at our 0.1 mole. So we need to calculate the difference from the new and the original value. The new value is going to be the one at the end. So this is the new one. So 8.9, we're minusing the original, which is 8.2. That's going to give us 0.7. So we found our difference. We then need to divide it by the original value. So remember, the original value is the number we had at the start, which is the 8.2. So we divide 0.7 by 8.2. That's going to give us 0.0853. Multiply that by 100 to get our percentage. That's going to be 8.2%. So we've calculated our 0.1 mole. We now need to look at our 0.3 mole. So again, we need to think of the difference. So our new number is 7.2. Our old number is 7.8. So minusing to get minus 0.6. We're dividing it by the number at the start, which is 7.8. That's going to give us minus 0.0769. Multiplying by 100 to get our percent. So here, we can actually see our result as minus 7.7. So we have a minus here. So that minus actually shows that's a decrease. So we actually have a decrease in the actual percentage here, whereas when we're comparing our 0.1 concentration, we can see there's an increase. So if we actually go back to our data, the mass at the start here was 8.2. The mass at the end was 8.9. We can see that there is an increase between these two numbers. So we know this is correct. If you look at our 0.3 mole, the mass at the start was 7.8, but the mass at the end was less, it was 7.2. So we know that minus is correct because it has lost mass. So now, if we wanted to try and apply this to some past paper questions, if we have a look here, we're looking at the pulse rates. So we're looking at some pulse rates here. So we need to calculate the percentage decrease in the mean pulse rate when lying down compared with when standing. So we have lying down compared with when standing. So we're just looking at the mean, so we're only using these two numbers here. So they've given us quite a few, but we're only using these two. So in the question, they want us to compare our lying down compared to standing. So lying down is the number we're going to use first. So here, our lying down is 69 minus our old, or what we're comparing against, which is 88. That is going to give us minus 19. So that's the difference between the two values. So remember, we're taking that difference and we're dividing it by the old number, or what we're comparing against, which is 88. That is going to give us minus 0.2159. Now again, we can't leave it as that. We need to actually go and multiply that by 100 to give us our percentage. So that's going to give us minus 21.59. So our answer here, according to our mark scheme, is our 21.6. So you can see here, even though we have a minus here, they haven't included that in the mark scheme. Now that's because they've already told you in the actual question itself that there's a percentage decrease. So we know that minus shows that our answer is correct. Okay, so we know our answer is correct because it's a decrease. So we've got a negative number at the end. So our next one, we're looking at vaccinations here. So a scientist tested 3 samples of blood from each patient. So he took a sample of blood 2 weeks before he dosed them with a vaccine, 2 weeks after the first dose of vaccine, and again 2 weeks after the second dose of the vaccine. So he plotted these in a graph depending on the mean concentration of antibodies in the blood at each blood test. So we need to calculate the percentage increase in the mean concentration of antibodies in the blood samples between sample 2 and 3. So here we need to try and find what our axes are actually showing. So if we have a look, so here we have 3. We need to go and find where this meets our axes and where sample 2 meets our axes as well. So we're looking at samples between 2 and 3. So we want to go and see the increase. So we can see here that sample 3 has a larger number compared to sample 2. So we want to see how much of an increase this is. So that looks around 37 in terms of our axes. We need to minus 2. So this is sample 3 here, sample 2 there. So that's going to give us a difference of 35. So if we then take 35, we're dividing it by the original, or what we're comparing against, which is sample number 2. So we're dividing it by 2. That's going to give us 17.5. But remember, we need to multiply that by 100 to give us our percent. So we're going to have 1,750% increase. So if we have a look at our answer, according to our mark scheme, that's exactly that. Okay, so we've got 1,750% increase in the mean concentration of antibodies in blood samples between samples 2 and 3. So if we actually look at our answer compared to our graph, we can see here that sample 3 is very large compared to sample 2. So we have some idea that that answer is correct. If we look at our next one, so we're looking at herbicides which are used to reduce the growth of our weeds here. Okay, so we've been given a number of different studies here, but if you look at our question, we need to calculate the percentage decrease in the yield caused by the use of a herbicide in study G. So we're only looking at study G here. So we need to go and think about what numbers we're using. Okay, so we want to go and see the cause. Okay, so we're going to see what has actually happened to the yield. So we're looking at the decrease here. So we can see this is a decrease here. So we want to look at where our decrease meets the axis and what our original number was. So not treated is our original and treated is our new. So that's what we want to look for. So we have that's around 10.8. We're minusing 11.7. That's going to give us minus 0.9. Okay. Now, from that, we take our difference, minus 0.9, divided by our original, which is 11.7. That's going to give us minus 0.0769. Again, we need to go and multiply that by 100. Okay, so that's going to give us our percentage. So we are going to have minus 7.69%. So if you look at our mark scheme, we have 7.7%. So again, they've already told us here that's a percentage decrease. So our minus here supports what the question is asking. So there's a decrease. So if we go back to our graph, we can see here that there is a decrease between the two results. So we're seeing the effect, the new effect, which is when we're using the herbicides compared to the old. So the original is when the herbicides aren't being used. So if we look at our last question, so we're looking at two groups of people. So group A are healthy, group B were recovering from an asthma attack. So using the data from the first second, so already we've been given information, we're only looking at the first second here. So using the data from the first second of forced expiration, calculate the percentage decrease in the forced expiration volume for group B compared to group A. So this is the mean volume of air breathed out during forced expiration. We're only looking at our first second here. So we are comparing group B. So group B is going to be our first number. So group B compared to group A. So we want to see where group B meets the axis and where group A meets the axis as well. Okay, so we want to see where they meet the axis. So our first number, so remember we're looking at group B, comparing it with group A. So our first number is going to be 0.8. We're minusing it by the original, or what we're comparing against, which is 4.2. That's going to give us minus 3.4. So we've got our difference, so minus 3.4 is our difference. We then need to go and divide it by what we're comparing against, or the original, which is 4.2. That's going to give us minus 0.8095. So again, we need to have this as a percentage, so minus 0.8095 multiplied by 100. This will give us minus 80.95%. So if we look at our mark scheme, we've got 81%. So again, they've already told us here that it's a decrease. So we know from our answer here that it is correct. So we have a decrease of 80.95%. If we go back to our graph and actually look here, so we want to see group B, we're comparing it against group A. So you can see here that there is a decrease. So there's a decrease when we're looking at them, which supports our answer for minus 80.95.